Now, students, good morning. Now, welcome to the video number 4. Today, I'm going to discuss the different types of polarization. Here, basically, there are 3 types of polarizations are there. One is electronic polarization. Electronic polarization. Similarly, orientation polarization. And third one is what? Ionic polarization. Normally they may ask you the question, that is short note on it. Write a note on the different types of polarization. Very easy to write. Okay, there is no mathematical derivations, only what simple, that is theory part, explanation. This electronic polarization is there, no, it occurs in all kinds of materials, all kinds of dielectric. Dielectric may be solid type, liquid type, or gaseous type. In all there is different types of dielectrics, all types of dielectrics, it may be solid, it may be liquid, or it may be gaseous, where electronic polarization occurs. First point. Second one is, you know that all noble gases, helium, neon, argon, krypton, xenon, and all that, it is in a monoatomic molecule, where in the monoatomic molecules there is no permanent electric dipole moment. What is there is no permanent electric dipole moment means where the positive charge and negative charges both are superimposed. When there is both are superimposed, there is no distance between the positive and negative charges, and hence the dipole moment is 0. Okay. Now I will take one. Let us consider one molecule. Here, it is in a cloud of what? Negative charges. That is in a cloud of spherically distribution. It is a cloud of negative charges. In this cloud, at the center, there is a positive charge is present. It is actually according to the old classical physics and all that. This is a cloud of what? Electron cloud. I will call it as a what? Electron cloud. This is what? Positively charged. Positive charge. It is a very old theory, that is. Here there is a both superimposition of what? Positive charge and negative charge is there. And hence, the net dipole moment equal to 0, because dipole moment equal to charge multiplied by what? Distance. But here, there is no fixed separation is there, so that r equal to 0, then dipole moment equal to also what? 0. Here, this is possible in case of what? Non-polar molecules. It is possible in non-polar molecule. It is a non-polar molecule. Example is, I told you, helium, that is helium gas, neon, argon, krypton, these are all comes under this category. Here now what I will do is, I will apply the electric field. I will apply it. What is the electric field? Electric field. When I apply the electrical field in one particular direction, that is, now I am applying the field like this. This is positive charge. This is what? Negative, that is. When I apply the electrical field, what happens? There is a dislocation of the positive charge and negative charge. This is like this. There is no symmetric distribution of the positive charge and negative charge. It is symmetric distribution. Here, the positive cloud or positive charge is here. It is entirely, it is what? Negative. Here, what you observe is, why it is dislocated is, this is the positive, you are applied the electrical field, so that all the negative cloud is there now, it is shifted in this direction. It is no longer, it is in a spherical symmetry is there. Now, there is a separation is there, this positive charge and net negative charge. Now, it is called as an induced dipole moment. Induced dipole moment. I am talking about each molecule I am talking, or each atom I am talking. Like that, several number of what atoms are there and all that. All together, that produces the what? Polarization. Here, the dislocation of the, I will define it. What is electronic polarization? The polarization, it is due to the dislocation of the electron cloud. Dislocation of the electron cloud. I will write it like this. Dislocation of the electron cloud. Okay. Definition I will write. Definition. Dislocation of electron cloud. Dislocation electron cloud. This electron cloud with respect to positive charge due to applied electric field, due to applied electric field is called electronic polarization. Electronic polarization. This is the definition. First you write the definition and write some 2-3 points you write it. What is the definition? It is a dislocation of the what? Electron cloud with respect to what? Positive charge due to an applied electric field is called as an what? Electronic polarization. Students, this electronic polarization will be what? Since electron cloud is there now, it is very lighter mass. Lighter mass is very, very less. So that it occurs within the time interval of what? 10 to the power of minus 15 second. It occurs very quickly, that is. It occurs very quickly, that is. Next is. And this value is mathematically, it is given by, it is alpha E, polarizability is given by epsilon R into epsilon R, epsilon 0 into what? Epsilon R minus of 1 divided by what? N. This is the equation. If you remember, you write it. Otherwise, no need of it. Here, the displacement of what? The negative charge will be what? Takes place under the influence of the what? Electric field. This is called as an what? Electronic polarization. That is. Next is what? Ionic polarization. That is. Next I will discuss ionic polarization. Okay. Now, ionic polarization will be occurs in the ionic materials. Ionic materials like sodium chloride is there, potassium chloride is there. You know that sodium and potassium, they have the what? Positive ion and negative ion. Here you see, in the absence of electrical field, what happens? That is, it is of course, it is one type, positive, negative, positive, negative. They are arranged in this fashion as you studied in the chemistry also. Here now apply the electric net field equal to what? It is 0 here. Applied electrical field is what? 0. Now what happens is there is a displacement of the positive ion and also what? The negative ion will be takes place. Displacement of what? Both positive ion and negative ion will be takes place. For example, now this is positive, no? This is what? Negative, because I am applying the field what? In this direction I am applying. There is a redistribution of these ions will be what? Ions will be what? Takes place here. How it is? I will tell you. Let us come to this set. Come to this set. This negative charge is what? This negative charge is moving like this. There is a this and negative and they are coming very closer. They are coming. And similarly, this also what? They are coming very closer. They are coming. Okay. So that dipole moment of each set of molecule, it will what? It will going to what? Change in this phenomenon. Because this negative charge is attracted by this and the positive charge is what? Attract. There is a slight, that is what? Redistribution of the positive ions and negative ions will be what? Takes place. Okay. Just you write only in one sentence. The polarization will be occurs due to the dislocation of the what? Ions under the influence of the electric field. I will write the polarization occurs due to the dislocation or dislocation of ions, dislocation of ions due to applied electric field, due to applied electric field is called ionic polarization. Ionic polarization. Here no need to draw the diagram for this. Just simply write only this much, it is enough. But since ions are very heavier, that is, ions are what? Very heavier compared to what? Electron cloud. When it is heavier now, in order to shifting or in order to rotate and all that, it takes more time. This t is nearly equal to 10 to the power of minus 13 second. In the previous case, in electronic polarization takes place within the time interval of how much? Minus 15 seconds. But this will takes within the time interval of 10 to the power of minus 13 seconds. Minus 13 is bigger as compared to what? Minus 15. Here electronic polarizability, just give it alpha E equal to E square divided by omega naught square into bracket M1 plus M2 divided by 2M1 into what? M. It is called as a not E, it is called as an ionic polarizability. It is called as a what? Ionic polarizability. Here you see what that is omega naught is the frequency of the applied electrical field. That means you are applying the alternating electrical field is what? It is applied here, not static field here. Alternating electrical field is what? Applied here. This is about what? Ionic polarization. It mainly occurs in what? It mainly occurs in the what? Ions, ionic materials. Here the positive ion is displaced towards the what? Negative plate, and negative ions are displaced towards the what? Positive plate and all that. Next one is, that is another one is orientation polarization. Now so far I discussed ionic, so what? Electronic polarization. Yeah. Students, this orientation polarization mainly occurs in what? The polar molecules. What are polar molecules? Polar molecules. Polar molecule. Example is hydrochloric acid, sodium chloride liquid and all. Polar means one is positive charge and what? Negative charge. Both are separated by what? Finite charge. It has got permanent electric dipole moment. Permanent electric dipole moment. But what happens? Each molecule has got dipole moment. But your system contains many dipoles. All dipoles are oriented in what? In different directions. That is what? Like this, like this, like this, like this. All are oriented in what? Different directions. So that the net dipole moment equal to equal to 0. Then polarization equal to 0. Then polarization equal to 0. This is a situation. Now if I apply the electric field, what happens now? Between the plates, all that is what? Dipoles are. This is positive, negative, negative, positive, positive, negative. You see, all are oriented in a particular order. They are oriented. That means when they are oriented, there must be torque is acting on it. This dipole is there. This dipole will be rotate. When there is a rotation, there must be a torque or there must be a torque is what acting on it. Each molecule will experience a torque on it. Now I will define it. What is orientation? Well, the word itself indicates that the polarization arises due to the orientation of the permanent dipoles. under the influence of electric field. What is this one? That is nothing but what? The orientation of the polarization. It arises due to the orientation of permanent dipoles under the influence of external electric field. Under the influence of external electric field. During this process, each molecule will be experiences a torque and all that. But students, here the time required is, it is 10 to the power of minus 10 second. The time required is 10 to the power of minus 10 second. I told you this. Electronic polarization, for electronic polarization, it is 10 to the power of minus 30. Next, ionic, 10 to the power of minus 30. This polarization will be what? 10 to the power of minus 10 second and all that. But one thing is, remember, one important point is, this orientation polarization is temperature dependent. It is temperature dependent. Important point. Temperature dependent. Even in the absence of the in the presence of electric field is also, it depends upon the what? Temperature. For different temperature, the polarization is what? Different. This is the, but earlier one, ionic and electronic polarization, they are not at all depending upon the temperature, but this one is depending upon the what? Temperature. Sometimes they may ask you the question, write down the comparison between the what? Electronic polarization, ionic polarization and orientation polarization. Here in the notes also I written that is, but only this polarization is what? Temperature dependent. And also here the molecules will be experiencing what? It experiences the torque in it. Here in the absence of the external field, here you write, in the absence of the external electrical field, here electric field, the net polarization equal to what? It is 0 and all that. Here I will write one equation. If you know this, remember, then you can write, otherwise no need of it. Here polarization P naught equal to N into mu square divided by 3 kT into what? E. This P naught equal to N into alpha orientation into what? E I am writing. What is alpha orientation? It is nothing but polarizability. It is nothing but polarizability. What is that polarizability? This quantity is that, no? It is nothing but polarizability. Alpha orientation equal to mu square divided by 3 kT. Since it is temperature is the denominator here, as temperature increases, then polarization is what? Decreases. Polarization decreases. Here also is the absence of electrical field because of temperature hesitation. Due to temperature hesitation, all dipoles are oriented in what? Random direction. That is, all dipoles are in random direction. Okay, sometimes they may ask you the question, write down the comparison between the electronic polarization, ionic polarization and orientation polarization. Or they may ask you, write a note on that. Whatever I discussed here, just I am explaining the briefly here. Electronic polarization occurs within the time interval of minus 15 seconds. This time interval will be what? 10 to the power of minus 13 seconds. This will be occurs within a time interval of how much? 10 to the power of minus 10 seconds. This is first point. Second one. Here it is temperature independent. It is temperature independent. I told you, only orientation polarization is for temperature dependent. This is temperature dependent. As temperature increases, the orientation will be what? Decreases. So there is a random arrangement will be there. And similarly, this is also temperature independent. Temperature independent. Next one, I told you earlier, it occurs in all dielectrics. In all dielectrics. That means dielectric may be solid type or liquid type or gaseous type. Especially in the gaseous type, helium, neon, argon, it exhibits only electronic polarization. No ionic, no orientation polarization. It occurs only in ionic materials. Ionic materials. Okay. It occurs, I said that, orientation. HCl liquid, NaCl liquid, and all that. Those are having exhibit what? Permanent dipole moment. It occurs only in polar molecules. Polar molecules. What are polar molecules? The polar molecules are the one which have got permanent electric dipole moment is there. They have got permanent electric dipole moment. But non-polar means there is no permanent electric dipole moment, but they are having the what? Induced dipole moment in the presence of what? External electric field. This is regarding the what? Regarding the different comparison between, that is, electronic polarization, ionic polarization, and orientation polarization. Okay. Students, now so far I discussed the different types of polarization and all that discussed here. Now there is one more, the sub part of it is internal field or Lorentz field. Lorentz field. It is purely, it is a classical theory, completely it is classical theory. Here you see, there are many dipoles out there. Okay. Plus, minus, plus, like this. Each dipole is considered as one student you can consider. All are oriented in different direction. This dipole now, this dipole 1, it produces some electrical field. Each dipole gives some electrical field is produced. So that this dipole is under the influence of dipole 2 is under the influence of electric field produced by dipole 1. I think you understood this. This is dipole 1, this is dipole 2. Okay. Now, dipole 1 is the now, this dipole, it 1 produces some electrical field somewhere here, electrical field. So that dipole 2 is under the influence of the electrical field produced by what? 1. In the same fashion, dipole 2 produces the electrical field. Now dipole 1 is under the influence of the electrical field produced by what? 2. Apart from this, you are applying the external electric field also you are applying. It means the field, that field is, there are two types of field. One is total field equal to applied field, that is external field, plus field due to each dipole, that is field due to what? Each dipole. This, whatever that this altogether is, now this is the net field. This I will call it as a what? Internal field. I will call it as a what? Internal field. I think you got this point. Internal field is what? It is because of two factors. One is due to what? Applied field or external field. Another one is what? Field due to what? Each dipole. So that the resultant field, the net electrical field experienced by dipole in a dielectric, due to the applied field and also field due to each dipole is nothing but what? Internal field and all that. Now we'll write the equation, that is the net electrical field, the net field experienced by dipole due to a applied electrical field and the field due to surrounding dipoles is called internal field, or sometimes it is called as a Lorentz field also. They will call it as a Lorentz field also. This internal field EI equal to E. I stands for internal field. E stands for what? External field. Plus P divided by 3 epsilon naught. If I write this equation, it is enough. No derivation, nothing for it. They ask a question, define internal field or Lorentz field. The net field experienced by dipole due to what? Applied electrical field, and the field due to what? And the field due to surrounding dipoles is called as an internal field. EI equal to E plus P divided by 3 epsilon naught. What is P? P is called as in what? Polarization. What is epsilon naught? It is called as in what? Permittivity of free space. Next is the derivation for the Clausius-Masuti equation. Students, from the point of examination, this equation is very, very important. That's very Clausius-Masuti equation. Derive the derivation of Clausius, C-L-A-U-S-S-I-U-S, Masuti, M-O-S-S-U-T-I equation. Important derivation. Okay, one assumption I am making here. While deriving this equation, I am taking the dielectric such that it produces only electronic polarization. I am not considering any ionic polarization or what orientation polarization, but I am considering what? Only electronic polarization. Okay. Many of the dielectrics, for example, I told you neon, argon, krypton, where in this case here that is a distribution of what? Negative charge is there, negative cloud, and at the center of this, what is there here? The positive charge. So that net dipole moment equal to what? 0. Such kind of molecule, we are calling it as what? Non-polar molecule. This you know that. It is a cloud of electron and this is the cloud of what? Positive. Both are what? Superimposed. So that there is no separation and hence dipole moment equal to what? 0. And such kind of materials, it is subjected to the electrical field. There is a redistribution here, negative charges, dislocation of the negative charges, and here this is the positive charge. Now dipole moment not equal to 0, here you are applying the what? Electric field you are applying. Here you see this dipole moment here, mu is directly proportional to the what? Electric field. If field is more, then the separation is more, then the dipole moment is also what? More. Then this mu equal to alpha is called as what? Polarizability. It is what? What kind of polarizability it is? Electronic polarizability. And this is the what? Electric field. This is EI. What is EI? EI is nothing but what? Internal molecular field. It is called as internal molecular field and all that. Okay. Now, here, can I write this equation? Because I am using this mu equal to alpha E of what? EI. This equation I am using. Second one. We know that polarization equal to, definition, recall it in the video 1. Polarization equal to net dipole moment per unit volume. Dipole moment per unit volume is called as what? Polarization. I am recalling all the terms which are equations I am using directly here. P equal to N into what? Mu. What is mu here? Dipole moment. What is N here? Number of dipoles per unit volume here. You see? It is N nothing but number of dipoles per unit volume. So that I am using this equation P equal to N into what? Mu I am using. Next one. One more term I am using here. This is P equal N I am writing mu equal to, we know that, alpha E of what? EI. Because mu equal to this. And one more electronic polarization, P equal to epsilon 0, epsilon R minus of 1 into what? This equation I am taking directly. I have not derived this. With this knowledge, I will derive the equation for it. Here remember, while deriving this equation, what I assumed here? The dielectric. That dielectric possesses what? Only electronic polarization, no ionic polarization, and no what? Orientation polarization. As I told you, that is a superimposition of positive and negative charges. Dipole moment equal to what? 0. Such kind of molecules are called as a what? Non-polar molecule. Now I will apply the what? External electric field applied. So that dipole moment is not equal to what? 0, because separation is there. So that this separation is depending upon the what? Electrical field. Mu is directly what? Depends upon the what? Electric field. This I will call it as a what? EI. Then mu equal to proportionality constant differences. This is proportionality constant. This is directly proportional. It is alpha E into what? EI. This alpha E is called as in what? Polarizability. And another definition of polarization is that there is net dipole moment per unit volume. This P equal to N into mu. I have written P equal to N into mu. What is mu? I know that P equal to N alpha E of what? EI. And one more equation is there, but of course I have written directly here. P equal to epsilon naught into epsilon R minus 1 into what? E, that is. Now I will start for deriving the equation. Now, internal field EI equal to E plus P divided by 3 epsilon naught. This is equation number 1. Next, here the polarization P equal to what? N alpha E of what? EI. Next, therefore EI equal to P divided by N of alpha. This is equation number 2. Next, this equation I'm writing. P equal to epsilon naught into epsilon R minus of 1 into what? E. Therefore, E equal to P divided by epsilon naught epsilon R minus of what? 1 here. This is another equation. This is equation number 3. Now I will substitute equation 2 and equation 3 in one equation. I will substitute 2 and 3. Yes. Now substituting this one. P divided by N of alpha E equal to this term. P divided by epsilon naught into epsilon r minus of 1 plus P divided by 3 of what? Epsilon naught. Now you see which is the common term in all the cases. Here I will rub it. This term I rub it. Here this P, this P, this P, this P get cancelled. What is left? 1 divided by n of alpha E equal to 1 divided by epsilon naught into epsilon r minus of 1 plus 1 divided by 3 of what? Epsilon naught. Now 1 divided by n alpha E equal to 1 by epsilon naught is the common. This is the common term. 1 divided by epsilon r minus of 1 plus 1 divided by 3. Now take the LCM and all that. Here 1 divided by n alpha E equal to 1 by epsilon naught divided by 3 into epsilon r. It is 3 plus epsilon r minus of 1. Here this term. It is 1 divided by n alpha E equal to epsilon naught. This becomes epsilon r plus of what? Divided by 3 into epsilon r minus of 1 here. Now can I write like this? That is 3 epsilon naught. I will bring it here. 3 epsilon naught divided by n alpha E equal to epsilon r plus 2 divided by epsilon r minus of 1. Or I will reverse it, both left side and right side. Here after reversing the standard equation, it is can I write epsilon r minus of 1 divided by epsilon r plus 2. This side reverse. Certainly this also reverse it, equal to n alpha E divided by 3 of 4 epsilon. This is important derivation. Okay. Now I will end my session today, and in the next video I will going to cover very small definitions and all that is there. Different types of dielectric breakdown is there, piezoelectric effect is there, and its applications is there. There is small definition and all that. There definitely will get 4 mark question you will get. It is completely this theory. There is different type. What is dielectric breakdown? What are the different types of dielectric breakdown here? And piezoelectric effect. And another one is electrates. What is electrates? Where they are using and all. If that we are going to cover in the next video. If I complete this one, next it will complete your syllabus. It is left to you how effectively you are reading all these things. Thank you, one and all.